Hello, everyone. Thanks for joining us. We're just going to wait a few minutes for people to filter in here. Okay. Hello, everybody. Thank you for joining us. Sorry, we just had a little bit of technical difficulty with one of our guest speakers here, but we're all good now and ready to go. So thanks for joining us here for the Canadian Grapevine Certification Network's now 5th webinar of 2022. This is another in a series of grape and wine research cluster updates that we've been holding throughout the year. Today's focus for the webinar is on the theme of sustainable management of soil, water, and crop quality. My name is Ethan Churchill. I'm the project manager for CGCN-RCCV. I'll be serving as your moderator for today's webinar. We're joined today by 3 wonderful guest speakers. We have Dr. Karine Pedneault, Dr. Mehdi Sharifi, and Dr. Kevin Usher. Go ahead and turn your cameras on so you can see your lovely faces. So just a quick note for everybody attending today. This webinar is being recorded and it'll be posted on our website in the near future if you wish to view it again or share it with colleagues. Additionally, I would like to note that the content of these presentations is the property of the researchers and authors here, and any use or distribution of the info can only be done with their permission. So enough of the legalese for now. A few other administrative notes before we dive in. We will have a question and answer period at the end of all 3 presentations today. So if at any point an attendee has a question for one of our speakers, you can type it in using the question and answer button at the bottom of your Zoom screen. We encourage you to ask lots of questions. Want to have a lively discussion at the end of our presentations here. And during the presentation, speaking of, If you want to change the size of the shared screen compared to the video feed that you have, if you move your cursor around between those two screens, there's a little double line and you can resize the presentation. So if it's too small for you, you can adjust it accordingly to make the presentations a bit easier to see. Before we get into the three presentations, I'm just going to give a very quick overview of the Grape and Wine Cluster and the theme for today's webinar. So the application for the Agri-Science Cluster was submitted back in January of 2018. The cluster activities had been built upon past research in each province to create a national coordinated effort to address key challenges in the grape and wine sector. Our application was approved in May of 2018 for $8.4 million in federal funding through Agriculture and Agri-Food Canada's Canadian Agricultural Partnership. And the application also included about $3 million in industry funding over 5 years for 23 different research activities. The last year of the program actually began just on April 1st of this year. So we're currently in year 5 of 5. Here are the main categories of the research activities broken down into a few key themes. You can see them listed here: science coordination, strategic management of grapevine virus diseases, cold hardiness and adaptation to climate change. Of course, the one we're here for today is sustainable management of soil, water, and crop quality. And this theme focuses on reducing the environmental footprint of grape production, conservation of resources such as water and energy, preservation of natural components of vineyard ecosystems, and the impact of responsible management on fruit and wine quality. The other activities you see listed there: optimizing the quality of Canadian wines, crop protection and monitoring, and knowledge and technology transfer, or KTT. That's all I wanted to share for you right now. If anyone has any questions about CGCN-RCCV or the cluster more specifically, feel free to reach out anytime using the contact information listed here or on our website. You can do that as well. So I'll stop sharing my screen. Karine, you can go ahead and get yourself set up, and in the meantime, I'll introduce you. Alrighty, so Dr. Karine Pedneault is currently a professor of plant biochemistry and metabolomics at Université du Québec en Outaouais, or UQO. She completed her MSc and PhD in plant biology at Laval University in Quebec and postdoctoral work at Laval University in the area of food sciences. Her current research focuses on the impact of moderate temperature increases on the ripening of interspecific hybrid grape varieties in Eastern Canada. Her goal is to better understand the relationships between terroir and grape variety at the metabolic level. Other research interests include the impact of climate change on other plant species and agricultural systems. Dr. Pedneault is the lead researcher for activity 9B of the cluster. And without further ado, I will turn it over to Karine. Thank you.
Thank you so much, Ethan, for such a great introduction. Nice to be with you today. I'm very happy to be able to share some of the work we've been doing, mostly in the last 2-3 years for the cluster. So today I'm going to talk about the plant temperature relationships, mostly with focus on secondary metabolites. So I'm starting right now. So all my work is focused on abiotic stresses and terroir. So obviously, there's a strong relationship between what we call terroir, so the abiotic conditions the grapevine will grow in. That includes light intensity and quality. It includes water availability and, of course, temperature. So besides those stresses that actually growers live with, they have impact on their crop through cultural practices. And this figure here illustrates that for this combo of conditions here, so cultural practices and environment, a single variety will provide different results. So in our case, we study these results using metabolomics. It means that we analyze metabolites in the berries, mostly in the berries, actually. So we work mostly in Eastern Canada, and Eastern Canada is not really a typical wine country. So I wanted to show that this figure here just to let you know what we're working with in Canada, well, in Eastern Canada, I should say. So typical wine area, and well, I put that with I don't know how to say in English, guillemets. Because there are multiple wine country in the world, so all different from each other. But typically, Vitis vinifera grapevine will grow from March and be harvested in October, or vice versa in the South Hemisphere. But in Eastern Canada, we have the same, mostly the same growing cycle, but it goes much faster. We have a very small, a much smaller window to grow this wine, to produce the fruit, and to ripe them. So it's really like a fast forward viticulture, and because of that, we tend to grow mostly varieties that are able to ripe within this short windows we live in. So of course, temperature in this process is really important. This is actually the main factor involved in berry ripening. So temperature will affect, for example, the ripening process itself. Of course, I'm going to talk a little bit more about that later on. But it will also affect berry homogeneity, for example. So if we have variation in the microclimate, it can affect the homogeneity of the crop. So it means that you can have like very much underripe berry besides ripened berry or more ripe berry. So so this of course will affect the wine quality later on. In the northern condition, typically we have higher acidities, and we can have lower concentration of varietal aroma, such as terpenes, C13 or isopenoids, and volatile phenols and others. So I'm going to talk a lot about those varietal aromas later on in the results I'm going to present you today. So so temperature will affect, as I said, multiple metabolism within grapevine. So the most well-known one are the impact on the primary metabolites. So it means bricks, for example, so total soluble solids here. So at a certain point, when temperature rise, like in places like California, for example, photosynthesis will just shut down, and so sugar accumulation will be slowed down due to temperature, to high temperature. But on the opposite, lower temperature tend to slow down photosynthesis as well. So of course, this will impact sugar accumulation in the berries as well. On the side of aroma, and I apologize, I left that in French, actually. I ran out of time. So on the side of secondary metabolites, mostly I'm going to talk about C13 or isopenoids and terpenoids here. So those processes usually get improved with temperature. So it means that higher temperature will improve the production, the accumulation of those compounds in the berry and sometimes in the leaves, actually, according to some studies. So how research hypothesis from the work I'm going to present you today is that increasing the temperature during a certain time during berry development and ripening will affect the composition of those berry at the end. So this is the typical graph we see for berry development and ripening. So of course, during these multiple phenological stages, different metabolic activities occurs. So it means that in the beginning of the ripening, the berry development, actually, we have green berries that are able to do photosynthesis. They are able to achieve some compound accumulation, and this is the time actually where malic acid will increase in the berries. And thereafter, when we switch to the second phase in stage 3, for example, usually we say that this is where aroma and flavors will accumulate. Color, of course, will appear during this time, and malic acid will decrease. So so we basically question how temperature affect these process. So we made an experiment that, and some of you might have seen previous talks I made about this experiment. So we hypothesized that if we increase the temperature in the first part of this process versus the second part, or not at all, or during the whole time of berry development and ripening, we wanted to see how this will affect the berry composition at the end. I stated a few hypotheses here that increasing in second stage, for example, will increase aroma, because this is where it's supposed to occur. See, the biosynthesis of aroma is supposed to occur in the second part of the berry, so during the ripening. The second hypothesis we had was about the whole increase of temperature during the whole season. So that means, well, that we thought that increasing the temperature during berry development and ripening was going to improve the crop quality overall, actually. So, but mostly with focus on aroma. So this is what we did here. Oh, sorry, I forgot to remove that slide, but I'm going to switch here, actually. So this is the treatment that we did. We've been putting those greenhouses on L'Acadie Blanc berries in Nova Scotia. That was done during the summer of 2020. And we've been testing greenhouses during the pré-veraison, during the post-veraison, during the whole season, and a control without greenhouse. And we've been sampling at different phenological stages. So during the green berries at EL32, and then during ripening, the very latest stages of ripening. We've been doing a bunch of measurements and mostly a free and bound volatile compounds. So I'm seeing the time running, so I want to get to the results, but if you have questions about that later on, I can explain. So what we first looked at is, did we succeed to increase the temperature during the time where we wanted to increase temperature? So we've been looking at the growing degree day accumulation in the pré-veraison and the post-veraison phases. So we saw that during the pré-veraison, globally, this is the treatment with the greenhouse for the whole season here. This is the pré-veraison treatment. So we had the greenhouses on during these, sorry, oh, thank you, Ethan, I can take my time. Okay, good. Yeah, sorry, I got a little bit disturbed with this comment. So we can see that the treatment that had the greenhouses during during pre and the whole season during this time, during the pré-veraison phase, had actually an increase in growing degree day accumulation, besides the one that were outside, which is the control, and the post-veraison. So those are pretty similar during this time, during the pré-veraison. After, during the post-veraison, we had an increase of growing degree days, mostly in the whole treatment, but also a little bit in the post-veraison treatment. And globally, what we could see is that the control, besides the whole season, we globally increased by more or less 200 growing degree days, the conditions where the grapevine have been growing during this season. So 200 growing degree days is quite a lot, but not that much, because it can represent the difference between one year to another. So in this case, we're going to look at the results, what it gives, you know, all these variation of climate. So the first results I'm going to show you actually are on berry weight, Brix, pH, and TA. So actually, most of these parameters were little affected by the treatments. We saw differences, of course, during the sampling, between sampling dates, but most you see, I put a few here, a few stages where we got differences, but overall there was little impact of the treatments on the Brix, pH, TA. So that means that increasing temperature a whole lot, like by 200 growing degree days, had little impact overall on the Brix, on the pH, on the TA, and on the berry weight as well. So that's that's quite interesting because it means that finally there's not that much of an impact of the temperature on the bricks itself. I know that bricks is a big deal for growers usually, so it means that we have a range to play with for a given variety. Of course, it can be different with another variety, but for l'Acadie Blanc, it was what we got from this experiment. I wanted to show you a little bit for sugar. Let's see for sugar. See here at the beginning, at the very earliest sampling we did at EL32 here, we get a little bit of a difference between the treatment that were under the greenhouses beside the ones that were out of the greenhouses. But thereafter, everything just merged. I mean, there was no difference for this actually. So yeah, that's the star. No impact of the treatment on berry composition for these, for sugars and for primary metabolites. For organic acid, we had slightly the same results, mostly no impact of the treatments on organic acid. And I apologize, I forgot to translate this. So no impact on berry composition. So, well, you know, it's interesting because when you go through the literature to look at the impact of cultural practices or even yearly variations in bricks, pH, and TA, it's not often, well, it's not systematic that we are going to have significant differences. So often, well, it happens that significant difference will be, you know, will happen, but it's not systematic. So so there's like a range of where we play, but we don't have sometimes much impact on certain aspects. So anyway, I will talk maybe about that later. But so I wanted to show. Yeah, sorry, I forgot to remove a few slides in this talk. I wanted to show you about the aroma now. So the aroma is the most interesting part of this trial because we did saw very much differences between the treatment. So what we saw basically is that the treatment that were under the greenhouses during the first part of berry development, so it means when the berries were green, those berries actually accumulated a lot more of volatile phenols than the control and the berries that were under the greenhouse in the second part of so during the ripening part, the second part of the berry development. So that's actually I put that as a to show you a few well, graphically sometimes it's easier. So basically the control out there had much more terpenoids and much more C13 nor isoprenoids than both treatment here, whole season and pré-véraison, that were under the greenhouse. So this is quite an interesting result actually, and let's see. And I'm going to develop more about why we've got these differences. If we take a look at 2-phenylethanol and benzyl alcohol, those are the main aroma we found in l'Acadie Blanc, by the way. So these are very important aroma for l'Acadie Blanc wine. So what we saw is actually the contrary. So in the whole and in the pré-véraison treatment, we have a whole lot of these 2 phenols, besides very little in the post-véraison and in the control. So we were quite surprised about these results because remember, we had maybe 200 growing degree days of difference between the control and the whole season in our grapevines. So we were mostly anticipating that terpenes and C13 nor isoprenoids will be the main, will be increasing in the grapevines that were under the greenhouse. So we've been questioning that a lot. We suspect that temperature obviously had an impact on the volatile phenols themselves. So it's been increasing those aroma. And later on, so we were looking at the terpenoids and the C13, and we were really wondering what was going on. And one of the things that we found out later on, and you can see this when you look at these grapes here, you can see that the pré-véraison and the whole season are much greener then the control and the post-veraison. So those were the berries that were exposed to sunlight during the first part of the berry development. So we suspect that there was an impact in our experiment, a side impact of the UV exposure. Of course, UV plays a role in the development of aroma in grapevine. So it doesn't mean that temperature didn't have the impact that we think, though, but it could be mixed impact from these two parameters. So for instance, yeah, I had an animation here. So those are the two treatments that were outside the greenhouse, well, at the beginning of the season. So if we get back to this graph here, we initially it's a well, how do you say it? So it's a well accepted idea that aroma accumulates during the ripening part of the berry development. However, it seems that what happens in this part here is very important as well. So we think that UV and temperature might impact here in this part of the berry development, of course, but there's also an impact of these parameters here. So, and this is quite unexplored thus far. We start looking more into that with other colleagues as well, but we think that there is much more of an impact here on the aroma that we'll get at the end. And what's interesting actually is that it's the phenol that we saw in the whole season treatment and in the pré-veraison treatment. Actually, the pré-veraison treatment never catched up. So it means that even though the pré-veraison treatment, we removed the greenhouse later on, it could never get as good as the other berries that were exposed to sunlight during the first part of the veraison, of the development. Sorry. So I'm looking for my words here. I'm not used to speaking English today, maybe lately. So yeah, let's conclude this part, and I will go more into those temperature and effect after. So temperature treatment had a limited effect on our primary metabolites. This is the first thing we found, but significantly affected the aroma profile, potentially with a role of UV in this aspect. And we know that by the way, UV, some genes responsible for terpene accumulation are activated with UV. So there's certainly an impact of UV here. In practice, it means that leaf removal, for example, and row alignment in terms of sunlight exposure are really important to increase crop quality overall. So especially in the first part of berry development. Also, and I say that because I see that there are some people growing grapes under greenhouses here in Quebec and in other parts of the world. So cultivation of vines under tunnels or in greenhouses could benefit from a supply of UV, probably, to allow the development to activate those genes related to terpene accumulation. And well, of course, improve the crop quality. So how that relates to terroir now. So this is the second part of this activity that we do for the Grape and Wine Cluster. So the first part was to understand the impact of temperature, as you already saw. But now we wanted to explore an interesting question, actually, which is how temperature accumulates during the season. Does that pattern of accumulation affects crop quality? So we've been taking two areas that have more or less similar growing degree days accumulation, one in Nova Scotia and one in Quebec. So those are pretty similar in terms of growing degree days, but in Quebec, the season is slightly shorter, and so it's warmer during the summer than in Nova Scotia, which is a seaside, so it's a little bit cooler. But overall, they accumulate the same amount of growing degree days. So we wanted to see how that would affect the aroma of berries at the end. So we did those sampling in Quebec and in Nova Scotia. We've been sampling a lot of different hybrids and Vitis vinifera varieties, and we're still in the process of analyzing those data. But I'm going to show you a few today. So the first thing I'm going to show you is l'Acadie Blanc in 2019. And we compare here Orléans Island and Grand Pré in Nova Scotia. So what we found basically is that there was differences between those two areas in terms of aroma profile. So it means that it's not that one or the other have less aroma necessarily, but they have different level of different concentration and different compounds. So it means that the aroma accumulation is different from between these two regions. So then I'm going to show you the annual variation that we saw, at least in Nova Scotia. So in Nova Scotia, 2019 was a cooler year and 2020 was much warmer actually. So here I only have 2019 from Quebec. It's, as I mentioned, still in the process of developing those data. But what we saw basically is that you can see that the variation between a cooler and a warmer year is not necessarily that big when compared to the variation we see between sites. So it means really that terroir has an impact, and terroir, now, I mean, I know it's not only temperature, okay? So there are a few other factors that can be, that could explain those results. So it's not only the growing degree day thing, but there are other aspects that were also including in our analysis of these data. But basically what we see is that there are much more differences between sites than between year to year on a single site. Yeah, so again, the aroma profiles are different between sites for this analysis as well. So it's really different compounds, different concentration, but also different compounds. Let's take a look at Riesling now. So Riesling in 2019 in Quebec and in Nova Scotia. You know that in Quebec and in Nova Scotia as well, but in Quebec particularly, there are more and more people growing Vitis vinifera varieties. So we're very much interested to see what those varieties are providing in terms of ripening, for example. So what we can see here is again that for a lower amount of growing degree days in 2019, slightly lower actually, we got again very different composition in our berries. And if we take a look at what it gives in terms of aroma, it's quite surprising that the berries that we sample in Nova Scotia actually add much more aroma than the one in Quebec. So there's, in this case, in contrast with l'Acadie, there's quite a big difference between what we get in Quebec compared to what we got in Nova Scotia. And again, I'm going to show you those in terms of graphs. It's going to be maybe easier to figure out what's going on, but you can see that for l'Acadie Blanc in Quebec, so you see it's Orléans Island, so it's two different growing degree, two ripening stages only. It's very close, you know, like 2018 growing degree days and 1022. So it's very close. They were sampled maybe like 10 days apart from each other. So you can see again that we have a lot more volatile phenols in these berries compared to the ones that we sampled in Nova Scotia. We also have a little more norazolprenoids in the Quebec berries compared to the ones from Nova Scotia. This is for l'Acadie Blanc. So remember, I mentioned that from the greenhouse experiment that that volatile phenols were much higher in the treatment that were in a warmer condition during the pré-véraison stage. So it seems that there's a relationship between how warm the season is and potentially the accumulation of certain volatile phenols. So this is still hypothetical at this point, but we think that there could be an impact of temperature on the development of those volatile phenols. And I can see from my own experiment that there are, well, and I think this is well known among viticulturists as well, that certain varieties are not made to be grown in warmer temperature. They can give a lot of volatile phenols. We saw that in certain varieties. So I definitely think that there's a relationship between higher temperature and the accumulation of certain volatile phenols in berries. Now, let's do the same exercise for Riesling. So what we saw for Riesling is that you see those difference in the temperature in terms of growing season itself did not impact the volatile phenols in this case, but it impacted the terpenes and the C13 isoprenoids that were in this case higher in the Riesling that grown in Nova Scotia. So what can we conclude from these results overall? Mostly is that, well, first thing I'm going to go in the order I put that on my slide, but so first thing is that cultural practice promoting early grape exposure could improve the terpene and C13 content of berries at harvest. So this is from the greenhouse experiment. But also similar amounts of growing degree days may lead to different aroma profile and some of aroma as well. So it can have, you can have more aroma with the same amount of growing degree days, and depending of terroir and probably cultural practices and other things. We're still in the process of exploring those results. So it's not something that you want to take like for granted. But so it's not only the sum of aroma, but it's also the profile. We saw that for a given amount of growing degree days, you can have different compounds that are accumulated preferentially compared to others. Also, variation observed between sites seems to be larger in general than annual variation on a given site. So, so site selection is actually very much important when you start a vineyard. This is something that sometimes I should say, maybe this is something people may neglect at some point because, you know, life, they got a place where they live, or they bought a place and they want to start a vineyard. So I think this is something really people should look more into when they do a site selection. And terroir, of course, is more than growing degree days accumulation and temperature. So there are other factors that are involved probably in the results I showed you today. But yeah, we'll keep going in this direction to understand better. But we can see already that temperature will give different results depending of the varieties as well. So yeah, I think that's pretty much what I had, and I think I'm in my time, Ethan. So thank you very much. So I'm ready for your question.
Perfect. Thank you so much, Karine. We'll do questions at the end of all the presentations.
Oh, okay.
So that's okay, but thank you. Yeah, so if anybody who's attending right now, if you have questions for Dr. Pedneault, please type them into the Q&A section, and we'll address them at the end of the final two presentations here. So merci beaucoup, Karine. You can go ahead and unshare your screen there, and we'll let Dr. Sharifi get himself set up, and I was
going to say, Ethan, that if people want to put questions in French, it's okay for me as well. I can translate or anything.
Perfect, thank you. Yeah, and no worries as well about some of your slides being in French. I think it's important considering that we are a bilingual country and a bilingual organization.
I will do a bilingual presentation next time. Yeah.
Yeah, it's perfect. Yeah, absolutely. I love it. Thank you so much. All right. So while Dr. Sharifi is getting himself set up here, I will introduce him. Dr. Mehdi Sharifi is currently working as a soil nutrient management research scientist at the Summerland Research and Development Center for Agriculture and Agri-Food Canada, where he has been since 2016. Before moving to the Okanagan, he was a professor at Trent University and Dalhousie University. He completed a 2-year postdoctoral fellow position at Organic Agriculture Center of Canada in 2008, and a 3-year postdoctoral fellow position at Fredericton Research and Development Center in 2005. Dr. Sharifi's research activities are focused on enhancing the environmental sustainability and resilience of perennial horticultural crops through ground vegetation management and use of organic soil amendments or health-promoting natural products. His interest extends to propagation and ethnoagronomy of culturally significant plant species. And Dr. Sharifi is the lead researcher for activity 10 of the cluster. I will turn it over to you, sir.
Good morning or good afternoon, depends on where you are. Thank you so much, Ethan, for the introduction. I would like to acknowledge that I'm joining you from West Kelowna, the traditional territory of Syilx Okanagan Nation. So the topic of my presentation is alternative vineyard management practices for sustaining yield and fruit quality and soil productivity. My co-author, Francisco Diaz in Pedneault, which lead the component on seaweed extract in Nova Scotia. Okay. And my slide, okay, it's slow. So we all know that several challenges exist affecting the fruit production, and in particular the grape production across the world. We all know about the environmental challenges, energy costs that is going up, especially we feel that now more with the COVID effect and also the war effect, security of the food supply, food safety and quality, and food sovereignty. So among these ones, the important ones that related to my work is more like looking at the agricultural resilience, environmental sustainability, looking at lower input to bring down the cost of the production, as well as improve the nutritional and health benefits of the crop. So we heard a lot about vermicompost or worm casting, as well as the compost tea or vermicompost tea. And literature shows many benefits from these amendments or spray. Increase in wine yield is reported, supply nutrients by especially vermicompost, enhancing the mycorrhiza fungi association with the roots with the vermicompost, suppress some of the parasitic nematodes, enhance grape wine yield and development with the vermicompost tea, and particularly on the vermicompost tea, there are a lot of reports on the suppressing powdery mildew and botrytis bunch rot. And the picture on the right is from the experiment. So we supplied 28 tons of vermicompost under wine. Another product that recently have received a lot of attention is seaweed extract. Many growers, they question that, okay, what is the effect of seaweed extract? Should we apply? How much we should apply? When should we apply? Literature shows with applying seaweed extract an improvement in the plant establishment, in the rhizoous stretch, which affect the diseases or reduce the diseases, increase set, enhance overall wine health and yield, improvement in the color uniformity when you spraying seaweed extract on the grapes, improve cold hardiness and reduce winter damage, which is very important for Canada, especially in the colder regions, improvement in the wine quality and reduction in the severity of the sour rot. So all these associated to the seaweed extract, and that bring us to this experiment that industry approached us and they had questioned about these products. So what is vermicompost effect? What is vermicompost tea effect and seaweed extract? And they were interested to know that is there any effect, first of all, on the yield or fruit quality, as well as on the overall health of the plant and on the soil nutrients. So these are the questions that we try to answer conducting this research. And for vermicompost and vermicompost tea, we have a trial in BC as well as for the seaweed extract. For the seaweed extract, we also had a parallel experiment in Nova Scotia. We measure a long list of different parameters that we thought they are important, and these treatments may impact these parameters. So I'm not going to repeat all these parameters in the following slides, and only present the significant parameters. So the parameters that show significant effect of the treatments. But this is the range: yield, cluster number, cluster weight, as well as berry mass, TA, soluble solids, pH, yeast assimilable nitrogen or yarn, Pedneault, nitrate, SPAD or chlorophyll, TCSA, which is the trunk diameter or trunk surface area, pruning weight, cluster compactness, winter hardiness, soil mineral nitrogen. We also look at for the vermicompost on the soil organic carbon and nitrogen. And this past year, we managed to also do some visual rating for the powdery mildew, as well as some measurement and some macroscopic picturing or imagery to see if there is any differences on the leaf surface for the vermicompost tea, because we wanted to see if there is any effect on the controlling diseases. Okay, so what I'm going to do, the way that I organize my slides is that I pose the research question on the top. So that's a question that we were interested to answer. On the right side, we see the treatments and in a red box, and for all the slides is the same. And then I presenting the results in the graph, and then I have some take-home message on the right that is going to appear later. So first question is that, does vermicompost tea? So we start with vermicompost tea. We did an experiment in Blasted Church in Okanagan Fall, BC. Does spraying vermicompost tea affect vineyard's yield or fruit quality? That's a question. Very simple. The treatments that we had a control that we just sprayed water. We had a grower control that we didn't spray anything, just whatever growers did. Sorry. We had 4 applications at a ratio of 1 to 12.5 compost to water. So 1 portion of the dry compost to 12 portion of water, or 13 portion of water. Second application, we had 4 applications, which it means monthly applications, starting from June, July, August, and September. So 4 applications monthly. And we reduced the concentration of the vermicompost to half. So we brew it to this ratio of 1 to 12.5, and then we diluted for the second treatment. For the 4th treatment, we had 8 application, means bi-weekly applied from late in May to end of August. And the higher concentration of these 8 application versus the diluted one, which is like 1 to 2 diluted application at 8 applications. So effect on the yield, we didn't see a lot of effect on the yield, and we didn't expect that. So it's a very dilute solution. It has a little bit of nutrients in the vermicompost tea, and it has a lot of organisms in that. So we didn't really aim and hope that the yield is gonna drastically change. So, and we didn't see that. In terms of the fruit quality, yes, we saw some differences. And here, look at the graph. 3 parameters show significantly affected by the spray: berry weight, titratable acidity, and bricks or soluble solids or total soluble solids. On the left side, on the y-axis, you see the berry weight and the TA. So for berry weight and TA, we're using this left side. For the bricks number, we're using, so I wanted to bring all three in one graph, so it's easier. Bricks number, we have it on the right side, vertical axis. And then we have the treatments in the bottom. First thing, let's look at the berry weight, is the blue color columns. And we see that, okay, we had 4 application low, 8 application low concentration is a little bit increased. And then we have 4 application with the higher concentration of the compost tea, very similar, except for the 8 application of the high that it's reduced a little bit. Berry weight reduced a little bit. And there's a debate, is that smaller berry is better or larger berry is better? It's a question for the winemakers, but in general, you see here in the bottom, I said the lower the berry size, the higher the phenolic compound or content. So there might be a benefit in having slightly smaller, but again, it really depends. In terms of the titratable acidity, which is that gray columns, you see that there is a little bit of change here, but again, the main change is that when you apply monthly 8 application with the higher concentration of the vermicompost tea, then you get lower titratable acidity. And we know that for Chardonnay, the grape variety that you see it here, all is Chardonnay. The optimum bricks is 22 to 25, and the TA is 0.6 to 0.7. So when we see that here on the 8 application high concentration, we see generally it seems it's doing relatively better. So the bricks is within the range, it's over 22. It's higher than the other treatments compared to the other treatments. The berry weight is slightly lower, so we may get more phenolics, and the titratable acidity is right on, it's 0.7. So the rest of the treatments, they had a slightly higher. So maybe this 8-time application of the non-diluted compost tea, it's doing something. So here, to summarize, although yield and fruit quality in vermicompost tea treatments weren't different from the control, so it wasn't huge difference with the control, but among the treatments, it seems that 8 application or monthly application during the season with the higher rate perform slightly better with the optimum soluble solid or bricks number and TA and smaller berries. Also, theoretically, if we're looking at the diseases control, we have a better coverage every 2-week spraying. So initially in this experiment, first year or so, we started doing that based on the growth stage, but then we noticed that no, it's better to consistently cover the wines with the spray. And here we say vermicomposting may provide a small positive effect on the fruit quality, but definitely the effect on the yield is very minimal. Second question, does the vermicompost tea spray affect the nitrogen status and the powdery mildew? So looking at the nitrogen status, we expected to see a little bit increase in the nitrogen because this spray provides a little bit of nitrogen. It's a very dilute solution. When you spray it on the leaves, some of that nitrogen is gonna get absorbed by the leaves, and we may get, so we saw the same thing. We had 4 application versus the 8 application. In 8 applications, these green bar, you see it's increased. So increased from the 0.53 to almost like 0.57 or 0.58. So a slight increase in the nitrogen in the petiole at Ryzen. And when we're looking at the juice pH, we see that again, when we had 8 application, we had a slightly higher juice pH by 0.1 or 0.2 higher. And that is expected because we're looking at the literature and it says you providing nitrogen to the wine and your juice pH is gonna increase, but still within the range. So Chardonnay, the optimum harvest pH is 3 to 3.3. So even with the little increase, we're still in that range. And the optimum Pedneault nitrogen at Verizon is 0.9 to 1.3%, which is low here. So that means this particular vineyard can benefit from a little bit more nitrogen fertilizer. And here is the message: is Vermicompost T does influence the nitrogen status of the wine, so that is good. And Vermicompost T may control powdery mildew to some extent with that biweekly application. And we saw the evidence visually, and we recorded, and also in the lab we saw that. And then when we took the imagery, again, we saw some evidence of that. So left, you see the water control, middle, you see the fungicide, which is the grower control, and then Vermicompost T. And these shiny green green stuff here, they are the fungi. And we see that when we have the vermicompost spray, the fungi are covered the leaves, whereas in the fungicide and in the water control, they are only on the midrib. So maybe we still haven't dig deep into that, and maybe we do a little bit more this year. Next question. So we finished with the vermicompost tea. We saw that there are some effect on the quality and on the nitrogen status, not much on the yield. Vermicompost, so that is an amendment. We apply it to the soil, and you see in the picture on the left that we applied 28 tons just under wine. And this is the dry matter weight. And if you're looking at the compost application in other cropping system, like these rates that we had, 7, 14, and 28 are very low. And these rates are only for under wine. So it's much less when you calculate it per acre, the whole acreage or hectare, it's even lower than that. This is what you have under the wine on the herbicide strip. So very, very modest rates, which make it economic because the vermicompost is slightly more expensive than the regular compost. So the rates or the treatments that we had the grower control, so fertilizers that the grower used. We had a control ourselves that we applied the other PK that the grower used, but we didn't add nitrogen. And then we have just 7 ton, 14 ton, and 28 tons of the compost or vermicompost. Here on the graph, left side, you see the juice pH. And then right, you see the cluster number or yield. So yes, the vermicompost, it affected the yield. And that's what we expected. So on the left side, you see the grower control. Look at the, only focus on the blue columns. So blue columns, grower control, we had about like 14, 15 tons per hectare yield. Our control, slightly lower because we didn't have nitrogen. So there is effect of nitrogen for sure. And when we have 7 tons, so it was low. This is how we designed it. We wanted to have that gradient increase and see what is the best rate of these vermicompost if someone is interested to apply and what's the effect. So the second rate 14, we got to the maximum. So we even slightly surpassed the grower control, but the difference is not significant, just the value is slightly higher. So 14 tons, we got very good yield, and 28 tons, no increase. So it means we're hitting the maximum. So the optimum for the yield, it was 14, and it's provided sufficient amount of nitrogen without needing any fertilizer. The second parameter is the juice pH. So juice pH, we see that in the grower control, it's very modest, 3.1. And as we apply these amendments, then the juice pH starts increasing, still within the range. So it's not like crazy high. So it's ranged between 3.1 to 3.4. So not too bad. And then we're looking at the cluster numbers. So number of the cluster, again, we see that it's comparable with the growers. So very similar, but there's some differences here. When we have the lower rate of vermicompost tea, we have the lower cluster number, and then that's why we have the lower yield probably. So the message is that the 14 tons per hectare dry weight basis of the vermicompost, just applying under the wine. And this compost has about 1% total nitrogen. It provides sufficient available nitrogen for the vines, but it also surpassed that. So there are other benefits. So that nitrogen is one main benefit, because we limited the nitrogen and we applied it to the compost and we saw the effect. And we applied that annually in this experiment. Juice pH increased we know that by nitrogen fertilization, it will increase. So we saw the increase here as the nitrogen increased, but it stays within the range. So that is fine. We looked at the soil. So we measured the nitrate and ammonium in the soil. Nitrate and ammonium are the main available nitrogen forms in the soil. So we look at the ammonium nitrate early in the season. I call it T1. Mid-season, I call it T2, and the end of the season, T3. So right at harvest. And in this graph that you see, the y-axis is either nitrate or ammonium. And the treatments are down here: grower control, control 7, 14, and 28 tons per hectare of vermicompost. And when we have ammonium, we see that it's that dashed columns. So those are the ammonium. And then when we have solid columns, these are nitrogen. So in the agricultural land or agricultural soil, we expect that majority of the nitrogen is nitrate. It just because of that fast conversion of the ammonium to the nitrate. So nitrate is very leachable. So it can leach very easy. If you have excess water, it will leach from the soil profile and you lose it. Or it can also turn into the nitrous oxide or nitrogen, and you lose it to the air. Ammonium is not like that. Ammonium has a positive charge. It can stick to the soil particles, so you will keep it. So it's always good, especially late in the season and early in the season, to have some ammonium in the soil, so that ammonium doesn't wash out, and then gradually it will convert or transform into the nitrate, and then the plant use it. So we see that in the grower, you see it's very modest, so very low amount of ammonium. And then when we're getting down in the mid-season, so these brownish color are the still early season nitrate, and then blue is mid-season, and then the green is late season nitrate. And you see that, so we have the higher concentration at the start of the season. As the plant growth starts taking up, we may lose some of that to the rain or excess irrigation. And then at the end of season, we're expecting to see the low concentration of the nitrate and ammonium. And these are the only ones that were significant, so I included here. In the control, very similar to what the grower had, 7 ton, 14, and 28. You see it's keep increasing. The ammonium increased. So we have quite a bit of ammonium at the start. And then we have also higher nitrate, which these are the range that we're expecting, about like 8, 10 milligram nitrogen per kilogram soil. So as we're getting to the 14 tons per hectare, we see that, okay, we have about 10 milligram nitrogen per kilogram. So it's good. And then later it starts decreasing to under 6. And then at the end of the season, it's manageable, so it's below 4. So we're not risking any losses during the fall and winter. So it seems that it's kind of managed the nitrogen in the soil, or available nitrogen in the soil, when we apply this compost. So soil mineral nitrogen regulated by the vermicompost with the optimum range achieved with the annual 14 tons per hectare dry weight basis under wine, and some effect where the residual effect of the previous application. So we saw that earlier in the season also we have a relatively good concentration of the nitrate and ammonium, which it's carryover from the last year, or residual effect. Next question. So we're done with the vermicompost. Now we're moving to the seaweed extract. Now, does the seaweed extract spray affect the vineyard yield and fruit quality? And this is that you see a big question for the growers. Seaweed extract is costly. Everyone want to know what are the benefits. I had the growers in Nova Scotia that he said that he saw that the clusters getting bigger, they're ripening faster when he already applying seaweed extract everywhere. So before this experiment, and he wanted to just kind of make sure that this is what is happening and what he feels that is there. So we conducted this experiment. We had 3 different rates. Control we didn't apply, or we applied water, sorry, 2.5 liter per hectare per application, 5 liter per hectare per application, which is the higher rate. So the rate that the company and be using Acadia sea plant seaweed extract, it's really recommending is about 2.5 liter per hectare. We thought, okay, let's go higher. Maybe if it's good, maybe more is better. That is not always like that. And the frequency, okay, we wanted to see when to apply it to get a better result. We had 3 spray, and we had 3 sprays plus 2 soil application, because we know that a lot of reports on the positive effect of the seaweed extracts on the roots and how it makes the plants to root faster. So I want to see that. And then 6 spray was the other treatment. So 3 or 6 spray, low rate of 2.5, high rate of 5. And then the dates that we apply, or the stages, we apply this one based on the stage of the growth. For the 3 application, we applied after flowering. For the 6 application, we provided 3 or 2 before flowering, and then the rest after flowering. And one last one, which is at the 41, which is after harvest. And for the soil, we applied it earlier on at the EL12 and EL15. So before flowering, we applied into soil. Okay, let's look at the results. The graph here, we see the berry weight on the left side, and then cluster number and yield. So again, we saw here, this year, in the previous years, we didn't see much effect on the yield. This year, we saw some effect among the treatment. It wasn't different from the control. So it just among the treatments, 6 application, 3 application, and low and high rate. We saw that, okay, when we getting, so these blue columns are yield. We see that it's increased when we go from 3 application to 6 application of the low, 2.5. A little bit increase, yes, in the yield. And then it's more or less the same when we have 3 application of high is very similar. And then when you have 6 application of the high, it seems the plant doesn't like it that much to have that high concentration, 6 times a spray on that. It seems like that. Berry weight, again, we see that we have a decrease in the berry weight when we going from 3 application after flowering at 2.5 to the other treatments. And cluster numbers, it's increased a little bit and then decrease. So well, it's some effect. So what I can say with that is that although yields in the seaweed treatments weren't different from the control, but among the seaweed treatments, when we compare those, 6 application of 2.5 liter per hectare, and we adjusted the pH to 6. Perform slightly better, and that pH was recommended by the company. Perform slightly better with the greater yield, larger number of clusters, smaller berries, and smaller berries because more phenolics there. But overall, the effect of the seaweed extract on the yield and yield quality was small. And we did such a good job, especially in 2021. Really, really great job by my master's students, my summer students, and technicians. So we were so careful, and we applied it very, very careful, and we really tried to get some effects there, if that, and because the growers were so excited about it. Here, the effect again continue. We see the cluster numbers when we compare it with the control, which is the first one. It has up and down, but most of the time the cluster numbers, except for the 3 application at 2.5, the rest are very similar. So yeast assumable nitrogen, no differences with the control, but among the treatments, We have a little bit up and down. So when we go to the 6 application of the low or 3 application of the high, we had lower, slightly lower yeast assimilable nitrogen, but within the range. So in Chardonnay, we expect more than 140 yeast assimilable nitrogen milligram per liter. It is good. So here I said minimum yeast assimilable nitrogen requirement for the low risk fermentation for the white grapes with Chardonnay is 150. Low yeast assimilable nitrogen concentration lower than that 150 or 140. It caused the inferior aroma and flavor, and even if they apply the supplemental nitrogen. So we try to keep it really in that range or over the 140. And we see that the yeast assimilable nitrogen, all treatments were within that range. So again, not a huge effect. And that all these, what I presented for the seaweed extract was from the BC. In Nova Scotia, similar story, bricks slightly increased, again, not compared to the control, but between the treatments. So when we had it, the lowest were in the, when we applied 3 times after flowering 2.5 liter, the bricks were slightly lower and then it went higher. So we look at the differences between the concentrations, and when we have a little bit higher concentration, we had a little bit higher cluster numbers, which I don't know it's beneficial or not. The juice pH, when we had soil application, this is interesting. We had a slightly higher the juice pH when we applied 2 times to the soil. So it might do something with the roots. So in Nova Scotia, seaweed had minimal effect on the yield and yield quality, definitely less than the BC, probably because of the climate. And again, we see the effect of, this is in BC, seaweed extract. We wanted to, the question was that, is there any effect on the nitrogen status? Is there any, we didn't expect that because there is no nitrogen in that, or very little nitrogen in the seaweed extract. What is the effect on the cluster compactness? That was a main focus for the company, that this is impacting the diseases, and also the bud hardiness is very important for us too. So we did these measurements in BC, and what we saw that, so cold hardiness on the left and a SPAD meter, which is the kind of indicator of the chlorophyll on the left, and Pedneault nitrate on the right. When not with the spraying on the plant, but when we had 2 applications in the soil, we saw some differences. So for example, cold hardiness, very little improved, like about 1 degree improved when we had soil application. And I don't know why. Is it just randomly, or it's a reason for that? I don't know. And then a SPAD meter and Pedneault nitrogen, they both indicator of the nitrogen, and we saw that they both from the left to the right, so 0 to 2 application in the soil, improved. So this is interesting because we always know that the seaweed extract affecting the roots, and this interaction with the roots caused somehow that a little bit more nitrogen get into the plant, which is interesting. So soil application of the seaweed extract had some effect on the cold hardiness and wine nitrogen status. This might be due to the interaction with the wine roots, and no significant effect on the cluster compactness. So we did measure cluster compactness 3 different methods, and we didn't see the difference. From this activity, we have several publications, 2 publications. One is just coming out, is under the 3rd revisions is done, so it's going for the press. And we had several presentations at the conferences. Take-home message, very simple. Vermicompost tea, seaweed extract provides some non-yield benefits. Bi-weekly application of the vermicompost tea at the ratio of 1 to 12.5 from June to end of August provide a good coverage on the wine leaves. And this spray provide a light range of the nitrogen and some evidence for the protection against the powdery mildew. So the growers got so excited about it, and he is going to spray the whole field with that to control the powdery mildew, because in our section we had, last year it wasn't too bad for powdery mildew, it was dry. but he had 9 applications of the fungicide. We had no applications in our block with the seaweed extract, and there was no differences. So that's kind of encouraging. And for the seaweed extract, if you want to apply, there might be some benefits from what we measured. It was very slight improvement, but 6 application at 2.5, definitely I won't go higher than 2.5 liter per hectare per application. And at these 2 times or 3 times before flowering, and then the rest after flowering. And also 2 soil applications seems to provide some benefits. What we got like the most effect was the vermicompost application in the soil. It's a great source of nitrogen, a moderate rate of 14 tons per hectare under vine, provide enough nitrogen for the vine during the season. It releases it slowly. So we didn't have to do a split application of fertilizer or so. The amount of release was more than 10% per year, and low risk of excess nitrogen and losses to the environment. So very pleased with this vermicompost here. So the experiment is going to continue this year, and lots of people involved here, different industry groups. Thank you so much to Arterra and Blasted Church for supporting the experiment. Acadia Sea Plants, Green Sciences Technology, which provided the vermicompost, Pedneault, CGCN, Government of Canada, BC Wine Grapes for the funding and the project. And some researchers helped me. Yushi took the imagery, Karen Fong measured the powdery mildew, and Kristen Hanna. And lots of students and technicians helped in this project. Thank you so much to all of them. And thanks so much for listening to my presentation.
That's wonderful, Dr. Sharifi. Thank you very much. It was very interesting. I hope some of our audience will have questions for you when we come to the Q&A. Last but not least, I'll call upon Dr. Kevin Usher here. He can turn his camera on, get the presentation set up, and I will go through an introduction. Just a reminder, of course, for our attendees, that Q&A button at the bottom of your Zoom screen there, that's where you can type in any questions for our panelists, and we'll address them after Dr. Usher's presentation. So Dr. Kevin Usher is a research scientist at Agriculture and Agri-Food Canada's Summerland Research and Development Centre. His research program focuses on the biochemistry of grapes and how vineyard site conditions and management practices influence organoleptic properties such as flavor and aroma to produce high quality wine and meet market demands. He has expertise in natural product chemistry and plant physiology. He conducts field-based research with industry and commercial vineyards, working towards sustainable production practices while improving quality by using advanced tools in chemical and sensory analysis. Through multiple collaborations, his expertise and these tools have been applied to the research areas of pathology, entomology, and whole plant physiology. Dr. Usher is the lead researcher for activity 11 of the Grape and Wine Science Cluster. Without further ado, I will turn it over. You are still muted there.
Okay, sorry, technical difficulties. I'm almost there. Let me start over.
Take your time. Perfect. We're all
okay,
good.
How's that? Okay, great. Thank you very much, Ethan, for the introduction. And just want to thank CGCN for the opportunity to talk about my research on nitrogen management to improve grape and wine quality. So I'm going to talk about a couple of objectives. This is a part of a larger project that I have, Activity 11 in the Agri-Science Cluster. And I've just shortened the title, but this is the actual title up top here. And I work with a number of collaborators who have made all this possible with AAFC and Summerland, Brock University, and UVic. So the 2 areas I want to talk about today are evaluating soil and foliar nitrogen application rates and frequency for their impact on grape quality and nitrogen content. And then also I want to talk about remote sensing or spectral imaging and precision management for vineyard nitrogen status. And these two objectives go hand in hand. So nitrogen is, of course, very important. Mehdi talked a bit about it here too. We have a couple areas where we can supplement nitrogen. And the main area is in the vineyard to supply vines with nitrogen. The nitrogen gets incorporated into all the plant parts, but for our purposes, grapes to make wine. The second area that supplementation might be important is in the winery, and typically adding nutrients such as diammonium phosphate is quite common. Nitrogen is required right from production in the vineyard through winemaking, and not only the plant uses it, but microorganisms, including yeast. And yeast act on different forms of nitrogen to survive. It's one of their food sources, along with sugar, and side products of that are a lot of flavor and aroma compounds that have sensory impact, and they affect the quality and price of wines. So I'm going to talk about yeast assimilable nitrogen a lot here, or YAN, and that's the nitrogen that's available for yeast to use as food, and those are free alpha amino acids and ammonium. The reason why it's important to get enough into the fruit for fermentation is because if we have low berry YAN, we can get stuck or sluggish fermentations. We can get production of hydrogen sulfide and higher alcohols. It also, if we don't have enough, it forces us to use supplementation in the winery, and this costs money and also changes the YAN profile, which changes the composition of important volatile compounds. So when the yeast convert, say, diammonium phosphate and use that up, it produces different types of compounds, flavor and aroma compounds, than what different amino acids may produce. So that the composition of YAN in fruit is really important to produce different complements of flavor and aromas in the final product, the wine. So why can't we just pour a bunch of fertilizer on or compost, whatever, to boost that nitrogen up early in the season? Well, if we do that, we end up getting excessive vegetative growth, lots of vigor, shading, and in the fruit and renewal zones, there's an increased risk of disease. We get poor spray penetration, and it's humid within the dense canopy like that. Also, the insects require nitrogen, and they feed on high nitrogen sources as well. It increases management costs when you have really vigorous vines, and it also delays maturation because of the basically cooling down of the fruit and an imbalance between vegetative and reproductive parts. And then this all leads to poor wine quality. So we really don't want to put huge amounts of nitrogen on early in the season. And we've done work where we've shown that when you do put high amounts on, you end up with a lot of vegetative aromas and unripe fruit at the end of the season. We can use foliar urea as a supplement to our regular fertilizer, and to boost the yeast assimilable nitrogen in fruit. And we get a reliable uptake through the leaf cuticle, and we have minimal effects on sugar and acid composition. It does modify the amino acid profile, so this changes the complexity of the wine, the flavor and aromas in wine, and it can also be used to reduce nitrogen inputs in the winery if we can boost YAN in the fruit itself. And of course, this changes flavor aroma profiles of wine and eventually the quality. So I'll give some just some examples of this. So we have done this on 4 different varieties. We started with Cabernet Franc and Sauvignon Blanc, and in our first year, and we had some challenges that we didn't foresee. Part of them was due to virus and pulling out the vineyard. So we didn't continue these experiments on, but we got some important information from those. So I'll show you a little bit about that. That was in 2018. Then we restarted with Sauvignon Blanc and Pinot Gris. And this is just a map of the Okanagan Valley. So we have Okanagan Lake at top, Kelowna at the very top where Mehdi's sitting right now. We have Penticton, this is Skaha Lake, and then just below Skaha, we have Thomas Ranch at Okanagan Falls, and that's where we have our Pinot Gris, and we have our Cabernet Sauvignon in Oliver and Black Sage. You can see these are very arid areas. These are the vineyards on the right side, and these are coarse textured soils, so they're sandy loam. And we set up these two experiments. These are very common setups. So we just go over these. So we have Cabernet Sauvignon and Pinot Gris set up very similar randomized complete block design. There are 2 different sites, 3-year study with 5 treatments and 4 blocks. And down the bottom here, we can see what the treatments are. And the next slide, we can go over those. So I have the first treatment is what we call standard management practice. So this is what the vineyard managers are doing already. And they just apply whatever they're doing in the vineyard across our experiment. And then we're going to layer on top of that some other treatments. So in addition to the standard management practices, we have 2 other nitrogen additions, and these are through fertigation. So the standard practice is 12 grams per plant, which is about 40 pounds of N per acre. And then the next 2 treatments are adding an additional 20% and 40% on top of this. Then we have 2 foliar urea treatments where we're applying 2% urea either twice or 3 times later in the season. And these foliar applications, we time them with when the fruit reaches about 10 degrees Brix. And we can see down in this chart at the bottom, just for an example of the typical timing. So the soil applications are going on earlier around fruit set, late June. Then we have our foliar treatments, again, based on that 10-degree Brix mark, but they're roughly spaced a couple weeks apart, 2 to 3 weeks, depending on the variety. And then finally harvest late September or October. We apply the foliar urea for our experiments just with a backpack sprayer, and we spray to drip. And we're sure to apply these on cool days because we're worried about burning leaves, which we never did see through the 4 years we've been doing this. So this is our first experiment, and which we only ran for a year, but we have Sauvignon Blanc and Cabernet Franc. And I'm just going to give you examples of data instead of showing you all the data for everything. But what I'm showing you here holds true for the Cabernet Sauvignon and Pinot Gris as well. We didn't find any treatment effects for Brix, pH, TA, berry weight, and yield in all experiments. So what I've done here is you can just see roughly what the numbers are. But for a Cabernet Sauvignon and Pinot Gris, I've just averaged by year what the Brix, pH, titratable acidity, and berry weight were. Just to give an idea of what their maturity was like for those years. So if we look at the nitrogen levels that we're finding, and this is why I wanted to include the Sauvignon Blanc and Cabernet Franc. This was kind of a learning year for us. We didn't see, this is total leaf nitrogen, so percent nitrogen, you can see on the left, and then our treatments along the bottom. So we have a control, 1 broadcast in. These ones were broadcast, not fertigated. And then we have our 3 foliar applications or 2 foliar applications. When we look at leaf total nitrogen, we didn't see significant differences between any of these treatments for Sauvignon Blanc and Cabernet Franc. When we look at the yeast assimilar nitrogen, though, we do see some increases with the foliar applications in Cabernet Franc. And in Sauvignon Blanc, there was nothing significant between these. So I wanted to show this because this is what we learned was, first of all, we are starting already at a fairly high level of the N in the fruit. So we can see in the Cab Franc, we're up around 200. This is adequate for fermentation. I mean, some people would add a little bit more, but we're already starting at a high level. So that's kind of one lesson for these experiments. You know, you may not need foliar application if you're already at a high enough level. The second thing what we learned was with Sauvignon Blanc, at this point when we were starting out, we were trying to apply during veraison, right at the start of veraison, and it was very difficult to catch that in a white variety. Plus, Sauvignon Blanc was harvested. If you saw the sugar numbers, they were harvested around 19 bricks. So the period from veraison to harvest was very short. And we think that they really didn't have enough time to take up the foliar urea and incorporate it into the fruit, which is why we think we're not seeing a result with the Sauvignon Blanc with increased yeast assimilar nitrogen. When we look at our Cab Sauv and Pinot Gris, this is 2019, so this is the first year we ran this experiment. And along the bottom, so along the left side, again, we have percent nitrogen in the leaf. And along the bottom, we have our sampling dates. And what I wanted to show here was we have our different treatments. So if you look at the yellow and the dark blue treatments, those are the foliar urea, and they were applied around beginning of August. And we can see there's an increase in leaf nitrogen. And that happens both in Pinot Gris over here and Cabernet Sauvignon. This difference, so I also notice that the axis goes from 1 to 2.8, so it's not starting at 0, it's been expanded a little bit. So we're looking at differences about 0.1 to maybe 0.3 of an increase in leaf nitrogen. But this leaf nitrogen, it doesn't carry over into the next season, so it doesn't appear to be stored next season. So what I'm showing here, I'm just going to focus on Cab Sauv now. But this also is occurring in Pinot Gris, where again we have, whoops, I've got the label. Left side, this is leaf percent N. Bottom is sampling dates, and with our different treatments. And what we see is our treatment applications were in early August. So by into September, we're seeing increases in leaf percent nitrogen with these foliar applications. Okay, so we see our treatments are being effective, being taken up. But really, so these are not huge differences, and they're happening late in the season, which is good. What's really interesting though is the yeast assimilar nitrogen content in the fruit, and this is really the result that we were looking for. We can see that with, so these across the top we have Cabernet Sauvignon, 3 different years. The left axis is yeast assimilar nitrogen content, and then we have our treatments along the bottom. And what we see is a fairly stark increase in foliar, in yeast assimilar nitrogen with the foliar urea applications. You'll notice the YAN content in all of these is below, for our standard practices, is below 150. And likely supplementation of nitrogen would be necessary when making wine here. So being able to boost up the yeast assimilar nitrogen by up to 2-fold, just by having a 2 or 3 foliar applications of urea, is quite substantial. And these levels that we're seeing here, you would not need to necessarily supplement your wine with other forms of nitrogen like diammonium phosphate or something like fermate. So this is great. The other thing that we find here is there is no change in vine vigor and the effects we get with early nitrogen application. And preliminary results with wines show that we're also not getting, high vegetative characters that you would often get with vigorous vines that develop early in this season. So just to wrap up this, the urea, foliar urea applications, we found that they can be safely applied to the canopies to increase fruit nitrogen content, and by up to twofold with 2 or 3 foliar applications. And it didn't really impact vine vigor, grape composition, fruit size, and yield, and only had moderate effects on leaf nitrogen, which didn't appear to carry over into the next year. Just a few notes. So urea has been reported to burn leaves if they're applied during high temperatures, so that should be avoided. And short early ripening or short period between veraison and harvest is more difficult to use this technique to apply urea, just because we feel there isn't enough time to have it incorporated into the fruit. And so then it seems to be much easier with later ripening varieties, and it's why we've seen better success on the red varieties that we've seen. And this is something that may contribute to the confusion in literature, where there's been a bunch of work done on this, and it's sort of sometimes it works and sometimes it doesn't. So this, in our experience, is what we found. And again, it's not this is not something to replace soil nitrogen applications. It's what I consider an amendment to try and boost yeast-soluble nitrogen in the fruit, or take care of any sort of late nitrogen deficiencies that may develop. Okay, so now I'll move on to the second thing I'd like to talk about, which is spectral imaging and precision management for vineyard nitrogen status. What we wanted to do with this is be able to eventually develop a model that can be used by aerial imaging, so using drones with cameras, to fly over vineyard blocks and provide estimates of areas with high and low nitrogen and what that nitrogen content may be. So I'll just go through sort of where we're at and what we've done so far. I want to say this is a really big collaboration with Pat Bowen, who has retired since, and Ben Ming is taking over for Pat at our research center. And so we'll continue collaboration with him. And very importantly as well, Brad Estegard, who has done most of the, or basically all the drone work and a lot of the imaging here. So we approach this from different aspects. So of course, we have the drones flying with different cameras on them and recording spectral reflectance. But we also do a lot of work on the ground. So we collect data like photosynthesis, metal conductance, transpiration, spectral reflectance. So we have an instrument that clips on the leaves, and it will record the reflectance coming off the leaves for visible and infrared. And SPAD measurements, which is a leaf greenness measure. And then in the lab, we collect leaf samples, fruit samples, and we measure nitrogen, pigments, like chlorophyll, carotenoids, and anthocyanins, which of course, chlorophyll is one of the biggest holders of nitrogen in the plant itself. And how we do this, we do all of this work on single leaves, and we record everything. So all the data that we collect, like the reflectance, all the lab data, photosynthesis is done on a leaf like this one shown right here. And we actually cut the leaf in half. We do some of the measurements on one side. We take these leaf discs. While we do spectral measurements on one side and photosynthesis on the other, we take these circles here, which we call leaf discs, and we use those for doing nitrogen analysis and pigment analysis. So half of the leaf goes towards pigment analysis, the other half for looking at nitrogen in the leaves. So in the end, when we combine all this data, what we're really trying to do is link up the wavelengths from our imaging. So these spectral reflectance data that we get is actually a bunch of visible and infrared wavelengths. We try and match which of those wavelengths is highly correlated with some of these analysis or data collections that we do. We use different types of indices, and these are aerial images that are using different images or different indices like ENDVI, green band reflectance, leaf canopy index. And what this does is basically it converts some of that raw data into something that we can use for making estimations on vine nutrition, for instance. We're also working on disease and water status. So this is just an example of this. In a few slides, I'll show you how different techniques we're using and how we're progressing is actually giving us a lot more options of the different types of indices that we may be able to use. So this is called nadir, and this is a GNDVI, and this is an aerial image from the top down. And the little green dots there are the vines in our experiment at Thomas Ranch. And those are all geolocated, so we know exactly where they are and what treatments are which. This has been overlaid on basically our red, green, blue image. So the red is the nadir image with reflectance spectroscopy. And if we zoom in, we can see it a bit closer. The red, or the areas that are shaded from yellow to purple, are the only areas that actually get measured. The ground is removed from these measurements, and this is all reflectance data. Each circle so the points are vines. Each circle around a vine represents a 100 centimeter diameter area, and that's where we're measuring. The data from that area is all averaged into a single value, so we have just a single value per vine. Within that area there's about 100 pixels, or we'll call them points per vine. With each pixel, that contains data of the different wavelengths that we're measuring its reflectance. So the amount of data is astonishing, and so that's why we try and boil it down into something we can understand and work with statistically. So this is a two-dimensional image from top down, and this is kind of the standard what people use in the industry, companies or researchers alike, to create some of these NDVI maps or other types of indices. We've been working a lot, and Brad's been working super hard on this to try and improve on this and use different methods. So this here is called a multi-spectral point cloud data. So it's different than nadir. And what this is this is also a 2D image right now, just looking top down like the previous one. But you can see all these little tiny dots in here. And instead of per plant having 100 points, using this technique or approach, we actually get between 1,000 or 4,000 points within the same area. So we can get a lot more finer scale and detail. One of the big differences between this approach is this contains three-dimensional data. So we have an XYZ axis. So we have latitude, longitude, and elevation for each data point. Plus we have 10-band multi-spectral data for each one of those points. So a tremendous amount of information. And really where the power lies in this is because we have that XYZ information, we can then take a look at different angles of the vine. And this is really, to me, this is really cool and stands out because instead of having just this top view, which is very narrow, and we only get the very tops of the vines, we can now look at each side of the vine where most of the canopy is visual. And of course, we all know that, depending on row orientation and which side of the vines we're looking at, they can be quite different from each other. So you can also see in this image that, well, we have 3 vines per group here. So those are our experimental units or treatments. And within those, you can even see all the little dots, and each one of these dots has a tremendous amount of information in it. So we can then boil that down and use some of these indices to bring the data towards something that we can actually use and correlate to some of the on-ground chemistry information, physiology information that we've gathered. So just don't pay attention really to the numbers or anything, just the colors on this, but I wanted to show you this because I'm comparing the nadir versus the 3-dimensional point cloud. And these are on the left here, all the different indices and types of platforms we can use to look at this data. And if we just look at the 2-dimensional nadir in yellow here, and this is, these are probabilities. So anything highlighted is 0.05 or less probability that our treatments are significant for these different indices. And just if you compare what we see with nadir versus point cloud, the 3-dimensional, the point cloud, at the top here, we have nadir, which is just top view. And then we can look at east or west sides of the vine with the point cloud. And it really opens up a lot more that we can do with these indices and a lot more different indices. So it's created maybe a lot more opportunity to develop some of these models. So if we go back, so what we're trying to do now with all this imaging data and these points of data that we have lots of different wavelengths of light that we're kind of picking out. We're trying to match these wavelengths that are reflected with some of the data. And I just wanted to point this out, some of the early work which is done, where we can link up whichever important wavelengths are linking up with some of the information like chlorophyll. So these are pigments that I've circled down here. And we're seeing fairly good correlations with those, whereas other things we're just, we don't see correlation. So we can start using this type of approach to start with developing models, matching those spectra up with our chemistry and physiology. And then we moved into, so this is measured nitrogen concentration in the leaves at the bottom, and then what we've been able to model with nitrogen over here. So this is predicted on the left side, and along the bottom is what we've actually measured. And what we're looking for are these points with a nice straight line through them, and this R squared of 0.9, which is really quite high. So we're really encouraged by this type of work that we're getting closer to be able to make predictions in the vineyard, linking up some of these spectral reflectance wavelengths with true nitrogen status in the vineyard. So this is measured nitrogen that we want to evaluate, and not just greenness, and there's a big difference between those two. So next steps. This is just a cartoon I've drawn of the types of experiments that we're doing. We've been doing this imaging on fairly controlled experiments, and where we apply nitrogen, we know how much. There's a lot of data coming out of these vines. What we want to do now is be able to move forward and apply this to whole vineyard blocks with some precision and accuracy. So the next step is to take it from a controlled experiment like this and set up a vineyard block where we've gone out and geolocated a number of vines. So that's what these red points are. And we call these sentinel vines. go out and measure all our physiological and chemical analysis that we would like to do on them, including nitrogen, of course, and keeping that to ourselves, flying our drones with their imagers over top of this, and making predictions on what the nitrogen status is on these vines. So we'll have a predicted value, and then we'll have the value that we've actually measured, just like in that the previous slide, and getting these regressions where we can develop models to predict in the whole vineyard. And if we can get a high correlation between those two, then we can provide maps or develop maps or provide this information to people that want to use it for predicting nitrogen status within whole vineyard blocks, so where we have areas of high and low nitrogen, which can then be precision managed. So with that, that's all I have for now. I just want to thank everyone, all the collaborators that we worked with, and the staff in the beginning. Of course, technical support. We have many co-op students and technicians that have worked on this. Thank you to them, and of course, our industry support. We've worked in Arterra and Andrew Peller vineyards, and they've been just excellent. And then finally, of course, Agriculture Canada, the BC Wine Grape Council, and CGCN for financial support. So with that, thank you very much.
Wonderful, Kevin. Thank you very much. I appreciate that. The three-dimensional imaging was particularly interesting to me. I love that. We do have a bit of time for a Q&A session. So if, yeah, there you go, Dr. Pedneault and Dr. Sharifi, if you want to put your cameras back on here. I did see a couple questions come up in the chat, so I'll start there. And if any of our attendees, if you have questions, you can use the Q&A section there to type those. I saw one question here for Dr. Sharifi. I think you just answered typed, but you can read it out here and expand upon it if you wish. Can vermicompost tea be applied through overhead irrigation? Can it be mixed with any fungicide or insecticide spray?
Yeah, thanks for the question. Interesting. I didn't think of that, but says if you filter the vermicompost tea and there is no small particles to clog the nasals, then you might be able to spray it with the overhead. In terms of mixing that with the fungicide and the insecticide, I really don't know. That's something to explore and see what is the impact, because what you want with the vermicompost tea is that when you brew it, you want to apply it right away. So you don't want to leave it for a long time, because you want that cocktail of the beneficial organisms to be sprayed on the plant, and you get the benefits. So so adding fungicide and insecticide, I don't know what would be the effect of that on that organisms, and that would be something for a topic for the research. Thanks.
Perfect, thank you. A question for Karine that I had actually. So I thought it was really interesting to see the difference between a vinifera variety, Riesling, and versus a hybrid variety, L'Acadie Blanc, in two different regions, two different terroirs. I guess I have a two-part question. The first being, do you think there would be any other differences or other plans to study other varieties, like perhaps red varieties, and see if there's a difference as well? And what would you say to growers in either Nova Scotia or Quebec who are trying to decide whether to focus more on hybrids or on vinifera?
Oh, that's a hard question. The second one. Well, regarding the reds, we've been doing a few studies prior to this one, and we've got some results in the past about those. And, when it comes to aroma, interestingly, if you're not among what we call the aromatic varieties, such as Riesling or Gewürztraminer and other Muscat, for example, there are not that many differences between red and whites. surprisingly. So at the end, of course, what we get in terms of results and aroma profile, depending of the terroirs and all abiotic conditions, is really related to, well, it's really per variety. So we need to study, but what we're trying to do actually with our project, and this is the very last year of that, we're trying to have a reference and see how this variety can, if this variety can be a reference for others. So we'll see how it goes with all the varieties we've been sampling and analyzing at the end, when we get all the database built on and with all the results. So then we can better model and see if we can actually use one variety as a model for the others. But thus far, what I can say, that phenol thing is really something going on actually, at least with hybrids. We know that, for example, some varieties, not to name them, like Sabrevois and Sainte Croix, if you grow them like these are reds actually, so if you grow them in warm temperature, they develop those very weird aroma, and some of these aroma are related to the presence of volatile phenols. We've been publishing about that in the past. So I think there's really a relationship between volatile phenols, the fact of accumulating volatile phenols and temperature. For your second question, so do we want to cultivate vinifera or hybrids? I think really, I would not split that in two, actually, between vinifera against hybrids. I mean, there are interests for both varieties, both kind of varieties. And I think at the end, you have hybrids that are very hard to ripen in the short season, as well as vinifera, you see. So at the end, the best is to get the proper variety for the growing degree days amount that a given site would have, and other factors that are involved in the decision that the growers do when they choose for a variety. It can be the style of wine they want to do. It can be how reliable the temperature will be from one year to another. It can be, do they want to do like late harvest, for example. So it can, there's how they want to grow as well, you know. Like vinifera is not easy to grow in a cold climate, and even, I mean, here in Quebec, they need to cover the vines during the winter. So this is already a bunch of work that maybe growers want to step away. It depends, you know, it depends really of, there are a lot of factors when it comes to decide for the variety. So not only the conditions, so.
Perfect, thank you. Yeah, Mehdi, if you want to comment on that, go ahead.
I just have a question or a couple of questions for Karine, and if there is time.
Yeah, please, absolutely.
Yeah. Okay, so using that greenhouse, Karine, why you think it is just the UV? Because that plastic or whatever you're using in the greenhouse, it may change the light intensity, it may change some of the wavelengths and composition of the light. So it might be a combination of these ones. Is there any reason that you think it's just the UV?
Yeah, so that's interesting actually, because when we've been selecting polycarbonate, this is polycarbonate that we used. I was actually looking for something that will not block UV, and it's really hard to find material that is not blocking UVs, although it exists. I know it now. I've been learning other things recently. So for polycarbonate itself, I've got the light transmittance. So basically the greenhouses we use has been reducing the light transmittance for the white light, and so everything visible, it was reduced by maybe like 10%. So it's not that much when compared to UV that was reduced by like 90% or something. So this is why we think that mostly UV was involved in there. And of course, you've got all this literature saying that there are those genes activated by UV, and these genes are activated in the first part of berry development. So, you know, one-on-one,
sure,
looks like it.
Yeah, and also the experiment you had in Quebec versus the Nova Scotia, you focused the differences on only the temperature and those, but do you think there might be some of the differences due to the soil that you see
Oh,
in the
yeah.
aroma on the soil management practices, because they don't do exactly the same management practices in the vineyard. So that might be.
So I would say the management practices are not quite that different from between Quebec and Nova Scotia. They mostly run using like VSP, for example, and the crop load are pretty similar. So we're still collecting those data, and I want to look into more the phenology also regarding this site. But definitely, soil is something that we need to consider in that aspect, obviously. So we're still collecting all those data. We have access to it. We have them somewhere, but we need to get all of them together. So yeah.
Okay, great.
Time
Thank
will
you.
see. Will let us know if what's going on here. So.
Thank you. And very quick comment for Kevin. I think, Kevin, the foliar application was on top of the fertilizer that the grower used. But the way that it's labeled, it seems like only you foliar applied 2 times or 3 times. But am I right or not? So the growers apply the fertilizer on the ground, and then you supply that with 2 extra or 3 extra foliar.
Yeah, that's right. So in that experiment, we didn't have true control with 0 nitrogen. And it's, I mean, you can do it, but it's not great for the growers.
Yeah. Oh, yeah.
But you're right. In the so the base level was what they did commercially in the vineyard, and then we added on top of that.
Great. Thank you.
Perfect. There is another question for Kevin in the chat here. Could the YAN be reliably measured in the fruits before veraison to decide whether foliar application would be justifiable? If so, how do you suggest to prepare the samples for analysis?
Yeah, so YAN is really interesting. It's a very good indicator at harvest time of nitrogen status in the plant, and it correlates really well with other types of analysis like Pedneault or leaf disc. But early season, it's difficult because it's as the fruit's developing, that nitrogen changes quite a bit. So we do an analyze early in the season, but making a prediction on whether your nitrogen status in the plant is at a level where you need to spray is difficult. So I would recommend for those types of applications, and I think this is what most people are doing in the industry, is going on historical data. So we know, for instance, down in Black Sage area, where very coarse sandy soils, nitrogen leaches away every year. We get very, very low levels, and typically they could benefit from foliar applications. Whereas in other areas where if you're constantly having high nitrogen, year after year, then you just need to use that data instead of trying to predict. If you want to predict, I would stick with doing the Pedneault analysis, or we find doing leaf blade analysis is even better than Pedneault, because leaf blades don't harden off like Pedneaults do, so the timing isn't as critical. But I mean, if you want to give me your contact, there is a couple papers out there that correlate some of these nitrogen measurements through the season, and that might be helpful. I could send that.
Sorry, I was muted there. Thank you, Kevin. Just a couple more questions here. This one for Mehdi. So applying 14 or 28 tons per hectare can result in significant increase of inputs such as tractor passes, transport of compost to vineyards, etc. This appears to be a significant increase on inputs, meaning greenhouse gas emissions. The results of applying these treatments appear to have a minimal effect overall. So what would be your answer if it is worth the increase on inputs for the benefits that are obtained?
Okay. Yeah. So this kind of looking at the cost, or looking at the environmental impact and energy, it needs a life cycle analysis. So to consider all the components, but a quick answer would be, so you comparing applying the vermicompost tea or any kind of compost with the nitrogen fertilizer. So the same amount, instead of the tractor goes and apply fertilizer, same tractor can go and apply compost. So it's not like a huge differences in the amount of tractor time or energy in that regard. It might be a slight difference, but not huge. In terms of the transportation, so there is, yes, absolutely same thing. So the transportation cost for and energy for the compost is more than the fertilizer, but the process of making the nitrogen fertilizer, it's very energy intensive. So that kind of like may balance that way. So I don't see a huge differences between the amount of energy we're spending here. For the vermicompost tea, so you need to have 8 applications or 4 applications, but we always do that for the fungicides as well. So you do 9 or 8 or 7 application of the fungicide. So same tractor time and same energy would spend. I do not see a huge, but to get an exact sort of number, you need to do a cost analysis or life cycle analysis and get the exact and compare those ones side by side.
Sorry, I keep muting myself and then talking. Thank you very much for answering that. Just one quick final question, I believe for Kevin. Is there any risk of increased ethyl carbamate in wine with foliar urea application?
Yeah, I think the risk would be, just putting way too much on. So if you're already at high levels and then you're applying more, then you run that risk. I haven't really seen it reported here. I mean, we typically have fairly low levels of nitrogen in our fruit here in Southern Valley anyways. I wouldn't recommend though just applying foliar nitrogen, foliar urea without measuring yeast assimilated nitrogen and kind of knowing where you're at with that. Because like I said, if you're already high, there's no need to apply, and you may just be causing yourself some problems down the road. So yeah, I think that would be a good cautionary note, is you really should be measuring your yeast assimilated nitrogen if you can. And I know it's difficult for smaller places, but I think it's well worth it, because it also gives you an idea of sort of where you're at with nitrogen status without having to do the leaf and petiole analysis, or you can match it up with that if you want. So I think that's a good question. I haven't seen any issues with ethyl carbamate, but in terms of foliar applications here in BC, but I also don't know how much it's being measured. So that's the other point.
Right. Perfect, thank you. And yeah, Karine, if you'd like to add on to that, please go ahead.
Yeah, I was just quickly going to add that the risk of ethyl carbamate is mostly, I think, related to hybrids, because in comparison with vinifera, we can hit like 600 milligrams per liter of juice of nitrogen. So I think at this point, and also depending of the yeast strain that is used for the winemaking, probably you can have some good conditions for ethyl carbamate production during the winemaking. But besides this, I think in vinifera it's not really an issue.
Yeah, thank you for your contribution there. It doesn't seem like we have any more questions, so that's good. I just have a few quick slides to wrap up with here. Obviously, first and foremost, I want to thank all of our guest speakers here today, Dr. Pedneault, Dr. Sharifi, Dr. Usher. Thank you for taking the time. I know it's a busy time of year for all of you, so thank you for taking the time to be here and share the results of your work with the Canadian industry. It's very valuable, certainly. And also just another legal point here to ensure that we can post this webinar recording on our website when we eventually do that. Just have to display these licenses. I just want to note again also that the information and the slides from today's presentations are owned exclusively by the authors and the researchers here, and that none of this information can be copied, used, or published without their permission. These presentations today are not complete publications. They're rather meant to serve just as an opportunity for the researchers to share the progress of their work to date. and we're grateful to have them here for that opportunity. Last but not least, of course, we do still have a few webinars remaining in our session for 2022. You can see them listed here. The next one coming up May 26th will focus on Pinot Gris virus and Syrah decline. And then we have a couple more cluster research updates as well, like the one we had today. So you can follow CGCN on Facebook and Twitter, subscribe to our email newsletters, check for updates on our websites if you want to be informed about the upcoming 3 webinars. The link to register for the one in May should be available in the next couple weeks. So you've got about a month now to prepare for that one. I did mention at the beginning, this webinar has been recorded, so eventually it will be posted to our websites and to our YouTube channel if you want to revisit or send the link to somebody who wasn't able to attend. Last quick note, when you exit the webinar here for our attendees, it'll ask you to complete a brief survey so you can share your thoughts on the session for today. We'd appreciate it if you could take a couple minutes just to answer this survey to show us how you thought the webinar went today and help us improve the future offerings that we have. So that's all for me. Once again, just a big thank you to our 3 guest speakers here. Thank you to all of our attendees for showing up to listen, and we hope to see you at our remaining webinars this year. So thank you very much, everybody. Enjoy the rest of your day, and I appreciate you being here.
Thank you so much.
Thank you.
Thanks a lot.
Bye.
Bye.